This is Project 5, video number 2, one in which we go ahead and code it up. Want to get the editor running, and then got to create a function. I'm going to call it function. I don't have to return anything, so not used. Function equals function name. I'll call it plot. It's f v versus t. And it takes two arguments, and I think they're v2 0 and k in that order, but better go back and make sure from the project handout. Takes the value of the speed of car 2 prior to the collision of the force constant, produces a graph from the instant it first makes contact with the car. Good, that's what the work was I did. But yeah, I got them in the right order. V2 and then K. And then I'll go space, or enter, end, and then my code will go in there, tab that over. I'm going to go ahead and save it. And let's see where I want to save it. Well, it looks like I'm already in my code, Project 5 my code, so that's good. So save it as the default file name there, save it, and go ahead and start. I had already tabbed over there. Keying this stuff in, what we had decided over here. So set. The first thing I got to do, I got the arguments. Set m is equal to 1,000. M equals 1,000 semicolon. I want that to be a lowercase m. Let's make sure that that's what I got. Looks like an uppercase m. Let's see if I got the caps lock on. Yep, that's what it was. And I guess I've forgotten already. My paint is delta t is equal to 0.1. Delta t equals 0.1, but that's the one I expect it might be changing. Put a semicolon after that. Let's see what else I had in mind. So I said to experiment with this value. Set n is equal to 1. Oh, and then set all my variables equal to 1. So I'll see x1 minus L0, see if I can remember that. But t of 1 is pretty important too. Wonder if I can make it so I can see both of these at the same time, because I got a lot of stuff to set equal to 1 there. I'm going to try making this window kind of small. And see if I can't see them both. Oh, you can see this one. If I make this one a little bit smaller, I got them both. I think that'll go a little bit faster. So I got to set n equals 1, t of 1. So the first element of the t array I'm building is equal to 0. x1 minus L0, that's what I'll call that variable, equals 0, x1 minus L0, and then x2 equals 0, x equals 0, that's the compression of the spring. Then up here, see if I can move over a little bit. So that was x equal to 0. So I got f1 is equal f of 1. So the force. I'm starting to build up the big old force array. F element number 1 is equal to 0. And then A1 equals 0. So at time 0, the acceleration of car number 1 is 0, and A2 is equal to 0. Both equal to 0. V1 is equal to 0. V2, I'd call that a mistake. V2, it's odd. I said there might be some mistakes, but I didn't really want them to actually be there. So let's go ahead and fix that up. Maybe I'll cross that out so you can see that there was a change. But V2 is V2 0 to 0, the initial value of it, the one that I got handed. So that was a mistake. That's fixed now. So V2 0 no, V2 is equal to V2 0. Alright. So do we have anything else? I want to look, see if there's a next line here. And so now I'm getting down to business with the while loop. So let's move down here, type in while. I think that's probably lowercase. While x is greater than or equal to 2. I'm going to try it like that. Well, x is greater than or equal to 0. I want to do all this stuff and then end. So I'm going to go one more and backspace till I line up with the while and say end. That ends the while loop, but all the contents of the while loop should be indented for the human reader. It doesn't matter for the program. So while x is greater than or equal to 0, I hope that's how you type that in, but we'll find out if we get an error. Bump up n by 1, n equals n plus 1. T of n is equal to n times delta t. So delta, I'm pretty sure I call that delta t like that. And then need some more space up here. That's t of n. So the next thing is my x1 minus L0 equals the same thing. I'm going to copy that. Control C, Control V, plus V1 times delta T. So if I'm spelling any of these variable names wrong, I just get an error and I'll have to fix that. But x2 equals x2 plus v2 times delta t. I want to make this a little bit easier to read, so when I'm tracking down mistakes, it's just for me. MATLAB doesn't care about that stuff, but I think it's easier to read if you get the spaces around the plus and minus and the equal sign. So that was x2, and then the stretch, or the compression of the spring, is just x2 minus, and Control V, I still got that variable stored on the clipboard, so that worked out for me. So then I'm up to f of n, the thing I'm trying to graph. Capital F, nth value, equals the stretch, the force constant of the spring times the compression. And A1, the acceleration of car number 1, is f of n divided by m. The mass, which I hope I set to 1000. I think I remember doing that. A2 equals minus A1. They both have the same mass, and the only horizontal force on each is the spring, but it's pushing in opposite directions. Rightward at one end and leftward at the other end. And then the code outline is so complete that this is all I'm doing is copying stuff down. Sweet. V1 is equal to V1 plus A1 times delta T, and then V2 equals the old value of V2 plus A2 times delta T. And then I think I already have my end typed in, and then I got a plot. So that's the end of the while loop. It's all lowercase and T comma F. Okay, I've done an awful lot of coding, and when I was writing that out by hand, figuring that out, so it'd be surprising if this ran right off the bat without errors, but let's go ahead and save it. Go over to the MATLAB control board and try plot F versus T with the spring constant velocity. I'll call it 2 meters per second, and then K. We want this. Let's say if we were to compress it 10 centimeters, it could hold the car up, which would be about 10,000 newtons divided by 10 centimeters. So about 100,000. I'm going to cut that in half so it could hold half the car up if it was compressed only 10 centimeters. So a pretty darn stiff spring. 50,000 newtons per meter. Let's see what happens here. So expression is not a valid target. So looks like line 6. Let's see what I got going on in line 6 in my editor. So 1, 2, 3, 4. Oh my. The lines are numbered, so I didn't have to count. I think I know where that came from. But I didn't do that anyplace else. Okay, let's save that. I mean, I was calling it X1 with a minus sign and L0, and I put it in parentheses when I wrote it up by hand. So that's probably where those parentheses came from, but they definitely don't belong there. So let's try MATLAB. Try running that up arrow, and then run it again. My goodness gracious. I got a plot as a function of time from a little surprised that it's linear. I wasn't expecting it to be linear. I think I guess I steadily compress the spring, and then it gets to a maximum compression. I don't understand why it's not showing the whole graph. Usually MATLAB's pretty good at figuring out how high up the graph has to go. The other thing is I seem to be going way beyond 0 before it stops. Let's try some I think the first thing I'll address this issue. It was supposed to stop, as soon as I got past 0, and it looks like it went further. So maybe it's just doing a couple of points because it's such a short time scale that this thing acts on. I was thinking 0.01. That's a relatively small amount of time, but I guess with that super strong. Oh, I typed in 0.1 anyway. I meant to go 0.01. I'm gonna divide it by 100 there. Try saving it. and then running that baby again. See what it looks like. Oh my goodness gracious. Seems to be working. So I'm in that regime again where I want to force the bottom to be 0. Don't really want to plot past 0. So go X lim, or it's Y lim. So Y limits equals Y lim. I think that's the way it went. So I'll save that. This is just a test to see if I got that right. Yeah, so it's telling me what the limits are, and I want whatever that one is. That was good, but this one I want to change to 0. So I think it's now. We went through this once before. I'll put the semicolon in there because it is doing what I wanted it to do. Y lim of, and then it's a bracket, and then the first argument, which is my Y limits, what they were set to, of 1. So the first element of that 2-element array, and that's actually wrong. I want the upper limit to stay the same, and it's the lower limit that I want to set to 0. So let's try 0 comma, and put a semicolon at the end of that. I don't think it matters, but let's see what happens there. And get something wrong, probably what I was just messing with. So yeah, never finished the function. So it's Y limit, and it takes 1 argument. So that 1 argument is an array, and the first element, it's a 2-element array. The first element is 0, and the second one is Y limits of 2, where Y limits were the automatically generated limits. So let's try that. I think one could put auto in quotes. I haven't learned from you guys, but I did need. Oh, I want to see if that actually works. That might be shorter. Alright. I think I can just put auto right there in single quotes. As in choose those automatically. So Control S. And no, didn't like that. So I was gonna credit one of you with that one because I think somebody used that auto idea in there the last time. I was thinking then I didn't even need that, but I'll go ahead and replace that with what I had before. It was Y limits second element of 2. I think the auto might be the whole array. Okay, Control S. I had it working. I should have left well enough alone. Let's go. Ba-boom. Take a look at the graph. And it does just go up to there. Alright, now the thing is, I don't really know if that's right. It does look like it goes up to 10,000 newtons, which I think we're talking 1/5 of a meter. Then I got compressed 10,000 newtons. Let me see what my arguments were again. I had 50,000 newtons per meter, so it's getting compressed 20 centimeters. If I put in, oops, I'm going to replace that 5 with a 10, so I'm putting in 100,000 newton per meter spring. Seems like it should get compressed. Well, it'll get compressed less. I think the graph will look pretty much the same. Went up to 15,000. Roughly 15,000, but same shape. Okay, one thing I want to check on is to see if changing the number of points matters. If I go to smaller points and it changes, then I probably wasn't using enough points. I mean, what we're doing is approximating an integral, but it's pretty I think it's a coupled set of integral equations that we're approximating here. And the smaller this is, the better the approximation should be. Because really what we're doing is saying during this time interval, the velocity and the acceleration are constant, which the velocity and acceleration are continually changing, but during a short time interval they don't change very much. So it is a good approximation if this is small enough. But what I got to see is whether or not stuff changes. So I think what I'll do is print out at the end, just for testing purposes, what x is at the very end. And that's how much the spring is compressed at the end. And if that changes when I change the number of points, then I didn't have enough points to start with. And when I say the number of points, the smaller this is, the more points I'm using. In other words, the bigger n gets. I'm taking smaller time steps to get up to the final time. I got to use more steps. But so if I make that smaller, that's the real thing. If I make the time interval smaller, it shouldn't change it if the answer was right in the first place. So I'll save that. Try running it where I'm getting to see how much the spring is compressed at the end, and that's probably not good. So let's find the max value of f. I want to test that a little bit. So you go. I don't remember how the maximum function works, but this is 1, 3, 5, 2. Just created a little array and try max of a. Let's see if I have to look that up. Max of a was 5, so that's how you pick out the maximum value in an array. So I'm going to try max of a force rather than. Going to go max compression as well. I think I'll go maximum of the force. So max of force. Just got it F. And I think I'll go the final time as well. So T of n. And I want to print both of those out. That's what I'm trying to do. I don't want to put semicolons on there. So let's try running it again. And I get what I was just testing rather than what I really want to look at. So I get those two values. So this was the maximum force, and this was the final time. I would expect the final time to change a little bit if I make smaller step sizes, because I can take smaller steps. So I should shave off something from the last digit there. But let's make it 1/10 of what it was. Put another 0 in and try again. Control S, up, and the maximum force staying the same. And yeah, I expected this to change .2223. I'm not sure I expected it to change quite that much. Well, looks like I had another 0 on there. Yeah, let's try dividing that by 10 again. So the max force is staying the same, so I think we're getting pretty accurate results here. We already had pretty accurate results. Let's see if I put another 0 in. Control S. So figure, nope, that lamp up, and so now it's taken a while. We got more time steps in there, so it took longer. The good news on the force, that's still not changing, so the very first value is probably good. And then the time keeps getting a little bit shorter, so as I'm taking a little step, that last step takes me past where I need to be is the real point of when I'm working it this way. I was thinking the last step, the last time step, it went 0.224, 0.222, and then 0.222 again. So I'm going to say this is essentially no change going from here to here, but this change seemed a little bit significant. So it's going to take the user a little while to. It was hardly noticeable time with that one, so I'll keep it with 3 zeros in there. I use a step size of 1/10,000th of a second, and my recollection is it didn't take. There was no noticeable pause. I ran it, and the output came out right away. When I divided that time interval by 10, there was a noticeable time period. So I'm thinking this seems rather realistic. As the cars collide, they get closer and closer together. The force builds up, gets greater and greater, gets up to its greatest value, and then comes back down to 0. And if I have a weaker spring, probably takes longer. There's a different amount of time as well, so there's going to be a different max force. What we really need is the area under this curve has got to stay the same. Because I think in compressing it, we got to do the same amount of work. In that you can look at it at that instant when it's totally compressed, the two cars, you got maximum compression, and after that they start separating again. So at that point, up to that point, it's as if it's an inelastic collision just for an instant there, and then the energy starts coming back out of the spring. And so the final velocity of both cars should be the same no matter what the force constant of the spring. It just in some cases takes longer to get there. But what that means, I got the same energy stored in the spring, which I guess the area under that curve doesn't have to be the same because that's not energy. So force versus distance, it would be the same. So that's not a good check. But I do see it going up and coming back down, which makes sense. And then let's see what happens if I do go with let's go with that 50,000 again. So change that 10 to a 5. We get doesn't go up to as big a force, but it takes longer. So that's kind of interesting. Let's say, in both cases the cars do get the same impulse, so the area under this does have to be the same in both cases. So it looks like a triangle, 1/2 of 0.15 times 10,000. That should be equal to whatever we got before, roughly. Okay, I'm actually pretty confident that this thing is working. A little surprised that it works so easily too, but keep in mind there was a mistake in the pencil and paper part. You want to make sure you fix that up before you turn in the pencil and paper part. I think I marked it in red, so whatever it was. Pretty easy to find. Easier to find for you. Let's see if I can go ahead and find that. Actually, I think it was all the way over here toward the end. Yeah, V2 is not 0. It's V2 0. Okay, so let's call that a wrap for video 2 for project number 5.